Hello, everybody. I hope you're all doing good wherever you are. So in this screencast, I'm going to explain to you how to analyze the data that you should by now have collected. So you've been conducting a line transect, and you have also calculated data that you can use to calculate the Simpson diversity index for two of the zones along your line transect. So I'm going to talk you through this and give a little bit of advice on the upcoming report as well. So to get started, this is the data that I collected. You can see that over here I have the data having to do with the abiotic factor, the light intensity, color, texture, and humidity of the soil. And these are then the plant species that I found in the different zones. And you can see that this is a mix of Danish and Latin and different things, English even. So these are just the very raw data that I collected. And I'm now going to show you how to then present this data in a more professional way. So what I've done is that I've used Excel to create tables to present that information. So this is the table that I've created that shows the abiotic factors. And together with each table, you should always have a little text underneath. You could also have it up here, a text giving the table a number and then explaining what it is that is in that table. And then in this next table, I have used all the information that was in my handwritten notes to create this table. Because presenting the data this way makes it a lot easier to then later on analyze it. So I have all the different zones up here, and then I have a list of all the different species that I have found along the entire transect. So when I look at my piece of paper, what I do is that I say, well, in zone 1, I had the first species I saw was this grass 1, and then grass 2, and then this one, and then this one. And then moving on to zone 2, I found again some of these, right? So some of them are the same, but then I also found this new one and this new one. So every time that you encounter a new species, you simply add it to the list. And then you put a cross if that species is represented in that zone. So you first do a cross for all the species that you found in zone 1, and then you do a cross for all the species you found in zone 2. And if some of the species are not yet on your list, then you add it. And same goes for all the other zones as you move along. And again, it's important to have a little text underneath explaining what it is that is shown in that table. Yes. And then this is the data that I will later on be using to calculate the Simpson diversity index of my zone number 1 at the top of my hill and zone number 5, which was the middle part of the hill. And what I need to do this is the number of individuals. So that's why I have shown the number of individuals, and then I have just a total number of individuals. And it's perfectly fine to have a total or a sum of some of the numbers even in your data presentation, right? Because this is just such an easy calculation to make that it's almost considered raw data, just summing up the numbers. So that's fine to have that. And then for the data analysis, if we take a look at the abiotic factors first, then this time that you can't really calculate anything, and it's given that the fact that most of this is qualitative data, it doesn't really make any sense to try to do graphs or whatever. So this will have to be a written analysis. So what you should then do is that you should write a text to sort of outline the findings. So there is more light at the top of the hill than at the bottom of the hill. The soil changes color from brown to black. This indicates that there is more organic matter in the lower zones. And the soil texture indicates that perhaps there's more clay, but it could also be simply that the soil is more humid at the bottom of the hill. And it seems here also when knowing about the different plant species found in the different zones, it seems that the most important abiotic factors, or the most sort of defining abiotic factor for the plant community, is the soil humidity, because it changes from being very dry at the top of the hill to being very humid at the bottom of the hill. So written analysis for this one. And then if you take a look at this table, then placing or presenting the data like this makes it easier to look for patterns. And when I looked at my data, it seems that there were at least some of these species that were only found sort of on the top of the hill or close to the top of the hill. There were some species that were located more in the middle of my transect, and then there were some species found only at the bottom or in the lower lying zones. And then there was, of course, this grass one that was found in almost the entire area. And then when actually sort of diving into this, you would also need to know a little bit about the different species. So you would need to look up some of those species found only at the top or in one end of your transect. What sort of defines them? What traits do they have? Do they prefer dry areas, and do the species down here prefer more humid areas? Are the species in the middle more competitive? Do they require a lot of light or whatever? So look up the species that you found, and use that information that you find in your analysis. Use that to describe what is it that happens, what changes do you see along the transect, and how can we use the abiotic factors to explain those changes. So that's what you should do. And again, it would require you writing out your analysis. And then just one more little detail. When I got home, I had this mixture of Danish and English and Latin names, right? So I have, of course, looked up all the different species and found the proper names for as many of them as I could. And these are all in Latin. What this means, Poaceae sp, is that this is a grass, but it's an unidentified species of grass. So I wasn't able to identify the specific species, so then I can use this abbreviation SP. And then to remember exactly what grass it was when I'm looking at my handwritten notes, and perhaps you should also include some pictures of some of the species, and then it's also nice to be able to refer to this as grass one. Because if I didn't have that name, then all my grasses would just be the same, right? I have the same for this Carex. I also have a Carex 1 and a Carex 2, but for the rest of them, I was able to find the proper Latin name. So you should try to get as far as you can finding the proper names for the species. And then for calculating the Simpson Diversity Index, this is the formula. This is just a screenshot from BioNinja showing the formula. So up here you have the total number of individuals. That would be 35 in zone 1 and 43 in zone 5 in my case. And then this is the number of individuals of each of the different species in that zone, right? So I would then sum the number of species 1, which is 27, times 27 minus 1, and then plus 5 times 5 minus 1, and so forth for all the different species represented in that zone. So this is the equation that I get for diversity index for my zone number 1 when I write it out, and I get an index value of 1.64 for zone number 1. And when I do the same calculation, but for the species and number of individuals in zone 5, I get a higher number, 4.13. And again, this comes from BioNinja. So it says here that a high index value suggests a stable site with many different niches and low competition. So there is high richness and high evenness. I explained a little bit about the richness and evenness in my last video. And a low index value represent few potential niches or few species dominating, so low richness and or evenness. So in my case, there is a higher diversity in zone 5 than in zone 1, and it makes sense because this was just much more like there was much more growing in this one, much more. The whole ground was covered. Up here I even had some bare soil once in a while, and I had few species, and yeah, and I had one of the grasses being very dominant, right? So this it makes sense when I compare my number to what I saw out there, that there is a higher both richness and evenness in zone 5, and hence a higher biodiversity index. Yes. So based on these explanations that I have just given you, I want you to get as far as you can with your data analysis. And then you should also start writing the report. And this time, more background information is required. So in the introduction, you should make sure that you actually describe the area in more detail, that you maybe already in your introduction write something about the most prominent species, the species that are most often found in the area. And then you draw on this background information in your analysis. And then also more discussion is needed here. And your discussion shouldn't just say something about, well, this is a good method, it can be used for many different things in many different places of the world. No, what's important in your discussion is that you evaluate your data and the reliability of your data. So try to not make it very general, but try to really focus on the fact that you have collected a lot of data, that some of the species were easy to recognize, but maybe also that once in a while it was very difficult to see, to decide how many individuals, for instance, were in the quadrants when calculating or when collecting data for the Simpson index. So a good discussion could start off with like a sum up of all your findings, perhaps something about the strength of the whole thing, and then a table where you sum up all the different possible sources of error. And of course, only the ones that you actually think have had an impact on your data. And then you explain in the next column in your table, you explain how that source of error have affected your data. And then you come up with a possible suggestion on how this could be solved, or how you could improve your method or your data collection to make your data more reliable. Yes. Good. So get started on this and post whatever questions you have in the chat, in the general channel. And the reason I'm asking you to post them in the general channel is because many of you have the same question as I imagine, and then it's much easier to see what I have answered other students. So let's have the conversation in the general channel. Good. That was it. Bye for now.